All right, gang, lesson 3.2, our continued work with fractions. In this case, we're going to discuss fractions and decimals, equivalent fractions and decimals. So your targets, when we are finished with the lesson, to be able to write fractions as decimals and vice versa, so to go both directions there, and to determine whether a decimal is terminating or repeating. So again, this is all review things. So just making solid some of those things that we've learned before. So, first of all, writing fractions as decimals. To convert a fraction to a decimal, we divide the numerator by the denominator. So when we have our little division box, the numerator goes underneath the box. The denominator goes out in front of the box. Okay, people try to do that backwards many times. And so the numerator goes under the box. The denominator goes out in front. Okay. Now, before we go to actually doing some decimal type things, first of all, let's repeat our types, or review our types of decimals. First of all, with our terminating decimals, and those are decimals that come to an end. And so, for example, if we go 1, this is 1/2. I just wrote it sideways. And here, let me bring my calculator down. If I go 1 divided by 2, you notice, and I'm doing this the quick way, 0.5, and this decimal comes to an end. Okay, that is a terminating decimal. The same thing for 3 divided by 4, just a couple examples, 0.75, it ends. It does not continue out as we go along. Okay, so our terminating decimals are ones that when we do division, they come to an end. Okay? Repeating decimals, all right, are decimals in which one or more digits repeat indefinitely. And we use a bar over that repeating portion to show that the decimal, that's a communication device. That's a way that we communicate to other people that we have this repeating decimal thing. So let me bring my, if I can get my calculator to, okay, it's having issues right here we go. Okay, and again, I'll show you on a calculator, and I know it's small, 1 divided by 3 equals, and you'll notice this is 0.333 and it goes on forever. And the thing we have to realize is the calculator itself runs out of space. We only have so many places on a calculator, but this decimal will continue forever. So when we write it, we will put the little repeating bar over top of the 3 to let everybody know that it's going to continue forever. Okay, or 3 divided by 11. Again, I have it sort of shown there in the box here, but you'll notice 27, 27, 27, 27. Oops. And now, in this particular case, you'll notice when I kicked it out here, it went 2, 7, and then 3. Well, the calculator, because it only has so much space, went, okay, the next number would have been a 7, so it automatically is programmed to round. This does not end here. Okay, this number does not end here. That's just as far as the calculator can take it. In actuality, it goes 27, 27, 27 forever, and it never stops. And so that's why we put, in this case, the repeating bar over the 2 and the 7. Okay. Now again, I did this the quick way, division in the calculator. If you have to, you do it out by hand. Okay. Non-repeating and non-terminating decimals. These are decimals that do not repeat or terminate, and you will run into these every once in a while. And I don't have my little calculator out here to show it in this particular case, but in a calculator, if you were to go the square root of 3, you would get a number that, in this case, the square root of 3 starts off as 1.7320. But then after that, the numbers that continue do not repeat, and they never come to an end. And again, it will get to the end of the calculator, and the calculator will run out of space. But we have to realize if it's not repeating or terminating in that amount of space, it's likely to go on forever without repeating and terminating. And so the best that we usually can do is to round them off, or we just leave some of our values. For example, the square root of 3, we might just leave that answer as square root of 3, knowing that we'll never repeat and never terminate. So. All right, write the fraction as a decimal. And so in this particular case, we are going to review our long division skills. Numerator divided by denominator, so 5 divided by 6. Does 6 go into 5? Nope. So add a decimal. because that's where the decimal would be at the end of 5, the whole number. So it's going to go up, add a 0. So 6 into 50. Well, how many times does 6 go into 50? Well, 8 times. Okay, 6 times 8 is 48. And subtract. Now, if you want to borrow this, you can, but I hope you know 50 minus 48 is 2. Add a 0, drop a 0. 6 into 20 is 3 times. 3 times 6 is 18. And again, if you want to borrow this one, you can. 2 is 1, and 10, and 2, and all that, but 20 minus 18 is 2. Add a 0, drop a 0. 6 into 20 again, 3 times, is 18. And you'll notice here, we are getting into remainder of 2, add 0, drop 0. We're going to have a remainder of, or not a remainder, a repeating 3. So if we do this, now if you want the 0 in front of the decimal, you can. It's not 100% required. A lot of people like it. I never picked it up. I understand what it is, but it's not required. I always used to leave it off. But so 83 hundredths, I guess, but the 3 part of this repeats. All right, 2 divided by 3. And I didn't actually mean to write it that way. I meant to go 2 divided by 3, because I already had it as 2/3. It's sort of repetitive. All right, we know the decimal will be right here at the end of the number when it's not given. So does 3 go into 2? Nope, it doesn't. Add a 0. 3 into 20 is, well, let's see, that's going to be, what, 6 times, right? Oh, sorry, the 6 should have gone up there. Yep, I make mistakes too. That's why you have erasers. And that's why we use pencil, and in my case, I have an eraser on my system. 3 times 6 is 18, and I subtract 20 minus 18 is 2. Add a 0, drop a 0. Oh, you'll notice again, 3 into 20 is going to be 6 times again, and that is 18. 20 minus 18 is 2, and so 0, 0, give me another 6. 0.6, repeating, 6/10. And again, if you want to put a 0 out front here, you can. You don't. It's not required. All right. Write the fraction as a decimal. And in this case, though, we are told to round to the nearest hundredth if necessary. I've got a place value chart down here, which I will get to in a minute, if necessary. Okay, so 5 divided by 2. Does 2 go into 5? Sure it does, twice. 2 times 2 is 4. That leaves me 1. Now my decimal in 5 is right there, so it will go straight up and add my 0 and drop it. 2 into 10, 5 times. 5 times 2 is 10. Okay, and that leaves me with a 0. So now I have a terminating decimal, but my directions here specifically say round to the nearest hundredth. Okay, well, small sort of issue, because if I look at my place value chart here, and I know it's small, hundredths is 2 decimal places. So I, in my answer, should have 2 decimal places. I only have 1. So I need another decimal place to follow the directions here. They say to go to the hundredths, so I need it. So the question in this case, what would the next number, because here's my tenths, what would the next number be? Well, this is a terminating decimal. Therefore, I know that I could add a 0 to it. I would not change the value, but now I have 2 decimal places. So to the nearest hundredth, this is 2 and 50 hundredths. Okay. So you get into some slippery little small things here of, does it make a difference to the number? And sort of the answer is no. 2.5 or 2 and 5/10 is the same thing as 2 and 50 hundredths. But if the definition, or if the directions say to round to the nearest hundredth, we probably should do it. Okay, so for technicality's sake, 2 and 50 hundredths would be the correct answer. Okay. Use mental math to place and place values to write the fraction as a decimal. Okay, so, and let me get the right tools out here. So what I'm going to do here in this particular case is I'm going to use equivalent fractions. I'm not going to do the long division method here. I'm going to use some of my mental math to come up with the fraction and the decimal. And I'm going to understand my place values in this particular case, because my place values, if I know my tenths and hundredths and things like that, if I can get this into a format that's tenths or hundredths or so on, hopefully I know the decimals off the top of my head. Well, 3/5, if you don't know the decimal for it, we can go by the way of tenths. Okay, 5 times 2 is 10. 3 times 2 is 6. So 6/10. All right, well, if I know my place values, again, here's my place value chart. 1 decimal place are my tenths. So if I were to put this in 2/10, 6/10 is 0.6, and since the tenths is 1 decimal place, it will end right there. Okay, so if I can get to tenths and hundredths and thousandths and so on with my fractions, I can use my place values in charts to help me develop the fractions. For example, 18/25. Well, if I don't happen to know that decimal off the top of my head, I know that 25 can be made into hundredths. How? Well, if I multiply by, not by 2, by 4, 25 times 4 is 100. Well, if I multiply the numerator times 4 as well, 8 times 4 is 32. Carry my 3 here. 4 times 1 is 4, plus 3 is 7. I have 72 hundredths. Well, again, my place value chart will tell you that 2 decimal places is hundredths. Well, okay, so 0.72 ends in the hundredths position. If you want the 0 in front, you can have it. But there's your 72 hundredths without having to do long division. Okay, so in some of these cases, you can use mental math instead of long division. And if you can, that is definitely preferable. And let me go ahead and fix this part here just before I go ahead, because it's just ugly. All right, there we go. During a football game, Albert completed 23 of 27 passes he attempted. Find his completion rate to the nearest thousandth. Okay, now that gives me a sort of a fractional idea. 23 out of 27. And the problem here, though, is 27 doesn't really go into like 100 evenly. So I'm probably going to have to do some division. Now, yes, I could set it up and do the long division method and go 23 divided by 27. I am not actually going to do that in this particular case. I'm going to cheat and use a calculator. Okay, there are definitely times, and here's the thing. Yes, I want you, if necessary, to be able to do 23 divided by 27 with a pencil and paper and do it out. But in this particular case, for the sake of time and so on, we are going to sort of skip that. We are going to go 23 divided by 27 equals. And now the one nice thing I can do here is I can bring that out. It's one of the nice little things. I know it's not very big. I can blow it up. Okay, but there is my solution using my calculator. All right, and let me get this out of the way now. Okay, so we are going to the nearest thousandth. Well, if I look at my place value chart, if I don't know this off of the top of my head, which I hope I do, tenths, hundredths, thousandths is 3 decimal places. So I need to go 3 decimal places. So I'm going to round those right there, 851. And basically it comes down to, is this 851, let me try a tool that actually writes, is this 851 or 852? 851 or 852. Well, and then we use our rules. So the next number is after the 1 is an 8. Well, 5 or higher here rounds 1 up to 2, and that's definitely bigger than 5. So that we are going to 2. So 0.852 is his completion rate to the nearest thousandth. All right, time for you to practice. Need help, come see me. Otherwise, good luck.